Hello guys, welcome to our YouTube channel. Sweet Science widens your horizon. In today's video, we'll be looking at measurements. Measurement. It is true of science in general and of physics in particular that its essence is measurement. No fact in science is accepted, no law established unless it is quantified and exactly measured. A law in science is not a law in the sense of obligation imposed by an authority like the state. It is a statement of fact arrived at after careful observation, repeated experiments, and accurate measurements. In science, we have the following measurements. Measurement of length. In measurement of length, we have the equipment that we use in measuring length. We have the tape, we have the meter rule, graduated in centimeter, 1 meter. We have the vernier calipers, we have the micrometer screw gauge. Let's talk about vernier calipers. The vernier calipers, here we have the analog, and then here we have the digital vernier calipers. In these digital vernier calipers, you can use it to take measurements accurately without suffering yourself to start reading what it has given you. It will just read it for you. You can watch it closely and see that it is digital. You just slide. When you slide, it will give you exactly what you want to measure. Now, but we are concerned with the analog vernier caliper. In this analog vernier calipers, you have the sliding jaw. You have two jaws, the bigger jaw and the smaller jaw. The bigger jaw is used to measure the external diameter. The bigger jaw is used to measure the external diameters, while the smaller jaw can be used to measure the internal diameter. Example of a test tube, of a cylinder, you can use this to measure this, the external diameter of the cylinder. You can use it to measure the internal diameter of also this cylinder. You can also use the vernier calipers to measure the diameter of a pendulum bulb. When you are asked during experiments, what is the diameter of the pendulum bulb? The handy measuring instrument is vernier caliper. Now you can also use it to measure the thickness of your meter rule. You take the thickness of your meter rule. Also, you can use it to measure the thickness of an exercise book. You can use it to measure the thickness of an exercise book, and then some other measurements you can also take with that. Now we now go to how do you read with this your vernier calipers? How do you read it? You have what you call the main scale division. Let me open it wide. Here is your main scale division. These calibrations are part of your main scale division. Here you have your main scale division. From 0 to 1, you have 10 small divisions. Between 0 and 1, you're having 10 small divisions. Now, I always tell students, you must know what the smallest division will be. You must. So, what will the smallest division here, what will it be? Since you have 10 to make 1, what will 1 be? 1 will now be 0.1 centimeter. 0.1 centimeter. So in reading this, you now have this is 0.1, 0.2, 0.3, 0.4, 0.5. This long line is 0.5, 0.6, 0.7, 0.8, 0.9. Then you have 1. And then the next one is 1.10. 1.2, 1.3, 1.4, 1.5 till you get to 2, 2.1 till you get to 3, 3.1, 2, 3, 4, 5 till you get to 4. Students are always finding it difficult to read this. So you have to pay attention to this. You make sure you know what the smallest division will give you. It's very important. And on this sliding jaw, you have lines not numbered. You have lines not numbered. They are what we call the vernier scale. How do you read this? You, after reading from your main scale, then you go to your vernier scale and look at the particular line that coincides with any line on this main scale. The particular line that will coincide with any line on this main scale. As you're seeing this, you now have, you now check. This is the beginning, the line. This one is coinciding with this long line. So you can now say that this line is coinciding and this line is number 1 coinciding with this long line. So if it's number 9, you will write 0.09. If it's number 1 that coincides, you will write 0.01 on your vernier scale reading. Now let's go to the board and then demonstrate for. Here you have vernier calipers being represented this way, and the question is always this: what is the reading of the vernier calipers drawn on the board? What is the reading? Now, remember we said between 0 and 1, you have 10 small divisions, and each division is 0.1. 0.1. So you have to write main scale. You write main scale, and then you also write vernier scale. You also write vernier scale. Now you have from 0 to 1, you have 10 small divisions: 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.5, you have the 1.9, and this is 2. And 2 is the last number on the main scale before the commencement of our vernier scale. I said always read the last number on the main scale before the commencement of the vernier scale. Now we have 2, so you now come and then write 2.00. We are recording in centimeter. Now you now go to your vernier scale. This is your vernier scale. Remember, you are looking for the line that coincides with any line on this main scale. This line did not coincide. No, 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 did not. No, you can see it. They are not coincide. And then we have here line 9 is coinciding with this line on the main scale. So we have 0.09 centimeter. You find the total, it will now give you 2.09 centimeter. That is the reading of this vernier scale drawn on the board. Thank you. Let's go for our activities. Students, you now do your own measurement for me to see. Let's go. I asked you to measure the external diameter and the internal diameter of your pen. Now, let me confirm. You said that the main scale is 2.04. How can the internal diameter be more than the external diameter? This is, okay, is this for the internal diameter or for the external diameter? No, which means you did not know what you did. You didn't know what you have done. Now, when I say measure the external and internal diameter, now the external diameter is this. Now we are getting, because you said main scale this, so you will write. You're supposed to write external diameter main scale, and then internal diameter main scale. That's the reading, the external diameter and then internal diameter. So this is not vernier scale. This is this no, just cancel the vernier scale and put internal diameter. Internal diameter. Yes, is equal to 2.0.0 centimeter. So from what you have measured, your internal diameter is more than your external diameter. Looking at this Bible now, the internal diameter should not be more than the external diameter, which means you got it all wrong. Now let's see. This is for my own now, the external diameter. The external diameter, remember I said the line, you're looking at the line on the vernier scale, on the main scale, the line on the main scale before the commencement of the vernier scale. And then look at the calibration. You are not having one inside. So it's even before this one that is inside. So the last line that you will read before the commencement of your vernier scale is 0. What? Is it 0.9 or 0.8? Check it very well. This is the commencement. See it here.
Okay.
Alright? So 0. What before this line?
Okay, 0.4.
Eh?
Yeah, 0.4.
No, it can't be 0.4. Look at it. Look at this is this line. Look at it. It's 0.5. 6, 7, 8. So the last line on your vernier scale before the commencement of the on your main scale before the commencement of the vernier scale is 0.8. 0.8. So your main scale here is 0.80 cm, and then you now check here for your vernier scale. Which of them coincides with any line on the main scale? Which of them? Count it. Number what? Number 8. So 8. So it's now 0.08 cm. So the external diameter is now 0.80 plus 0.08. So calculate, what will it be? 8.0 centimeter. So this is your external diameter. Then your internal diameter, you close your jaw and then you open it. Alright, close it and then you now read again. External diameter. So what this is internal. We are now reading the internal diameter. So what is it? You now check the line on the main scale before the commencement of the vernier scale. What is the last line? It's not 4. This long line is way out. This is 4. This is 5. Alright? And then I think it's the 5, not 4, because this is the commencement of your vernier scale. It's not. So the 6 is 0.60. So for internal diameter, you now have 0.60 cm, and then now check for the line that coincides with any line on the main scale. The line that coincides with any line on the main scale. Number what? Count it. 9. So it's 0.09 centimeter. Because this vernier scale measures to the accuracy of 0.01 cm. So the accuracy of 0.01 cm. So we now have 96.0 cm. So for this your pen, the external diameter is what? 0.88 cm, and then internal diameter is what? 0.6 9 centimeter. And from this, you can calculate the thickness of this. And the thickness is what? The external minus what? The internal diameter. Thank you.